So I will talk about IFC 4.3, which is important standard for especially for the infrastructure domain. Sorry, again, I'm trying. Something happened to my connection. So I need to wait maybe. So maybe I can somehow. It's all about the connection probably. Oh yes, now it should work. Almost. Yes, now. Perfect. So again, nice to meet you. My name is Marcin Pszczółka. I'm working for Trimble, but also I'm a co-founder of Beam Corner blog. So maybe you had a chance before to read some text on our blog. So we are mostly posting about BIM and new technologies in AEC and industry. So first of all, thank you for having me here. It's a pleasure to be part of this community. So as I said, I would like to talk today about IFC. So before we jump to the IFC 4.3 standard, I would like to also show you how the current situation looks for the infrastructure domain. So this is the basic road, and what you can notice here that this road is presented by IFC entities, but these entities are more used for building construction. So for example, to divide my road, I use buildings, building stories or slabs. So this is how the reality looks today. This is another example of IFC data, also describing some landscaping, but in this case, I use some proxy objects. So in the reality, this is how the projects or how the IFC files are delivered or exchanged. So we have a lot of proxies, a lot of objects that describe some miscellaneous objects without any sense. And it's very hard to exchange data and make standard on top of that for infrastructure domain. So what is the evolution of IFC standards? So why it's like this today? Because what we know, this is what we know already. It's IFC 2x3 standard or 2x3 and IFC 4, and we have it almost for 20 years. And recently, this year, we got a new standard called IFC 4.3, and already is certified, ISO certified, so it means that we can also require it in the projects, but it's also depending on the level of implementation. So I will also refer to that later, but what I want to speak about is what is new in this standard IFC 4.3. As I said, we had privilege, or we had a chance to use IFC 2x3 and 4, which was mainly focused on the buildings and constructions. So with new standard, with new extension, we can also cover areas, domains like bridges. We can also describe roads, railways, geotechnical elements, or ports and waterways. So this is the typical example of the road model. So if you can notice now, there is plenty of new entities, new classes that could be used to describe more precisely our projects. So for example, for structural layers, we can have IFC cores. For earthworks works, we have a special entity called IFC earthworks field. We have also some objects that can help us to describe terrain. What else? We can also describe signs and other elements that are used in the infrastructure designing. Another example, bridges. Here is not the revolution but evolution. So there is the same, almost the same number of entities, maybe few new, but what you can also notice written in this capital letters after the class. So the IFC, for example, pile is a class. Then we have a dot, and there we have the capital letters. And this is something called predefined types. So instead of adding new classes, we have attribute called predefined type. And this predefined type help us to even more precisely describe our data. So for bridges, we have also entities and predefined types that can be used to cover this domain quite extensively. The same situation with railways. We have also entities that could be used to describe like track elements, sleepers, rails. We have also part of the embankment, so that kind of stuff that designers used to design. So this is, as I said, revolution for our domain, that now we can close or work together with another interdisciplinary experts and deliver model having the same language. So this was the first thing that changed, that new number, or the total number of entities that could be used in the industry to describe infrastructure elements. But what else? As I showed you in the first slide, something what is very unique for IFC is this decomposition. So decomposition is something called spatial breakdown structure. So we always have on top of the project something called IFC project. Then we have IFC site, and these are two mandatory entities that you have to include in your model. But in addition, we have something called IFC building, which is the top level, and then we have a building story. But now, for infrastructure, there are new entities like IFC road, IFC railway, IFC marine facility, or I don't remember for this part, but IFC bridge. So now, using them, we can distinguish our models, and we can easily attach these entities to our models. So this is also something new. And spatial breakdown structure is used in different viewers. So you have snapshot from different viewers. So when you open your IFC file in any viewer, every time you have this tree structure. As I said, we're on top IFC project, site, building, or bridge. So this helps us now to structure our data even more precisely. So this is the newest thing in the IFC standard. This is example of the composition. So you can see now that railway could be decomposed in several parts. In this case, we have IFC railway part, but which only contain objects related to track, for substructure, above track, or some line side. So, and these spatial objects, we should treat them as containers, like groups. They can have geometry, but majority of them have no geometry. It means that they are like placeholders for our kickable objects. I call them kickable. It means that these objects I showed you before, they have a geometry. So IFC slab has geometry, IFC wall has geometry, IFC course has geometry, but IFC railway part or IFC railway, they are just placeholders. So you have to also distinguish, if you do mapping from your application, never attach your geometry to these entities. This is also a common mistake that sometimes people think, oh, we have a railway part or bridge part, let's use them, let's map them to our data. No, they are just to structure our project, our IFC project. Next thing, which is very important for infrastructure domain, And if you ask me what is the main difference between constructions, vertical buildings, and infrastructure, I will say this is alignment. So alignment is a linear object which contains curves, straight lines, but also transition curves like spirals. And this is also something unique because the mathematics behind is so complicated. That's why release of IFC 4.3 took 10 years because of this specific object. Because just adding extra entities, this is not the issue, but the mathematics and actually different approach in different countries, like in Switzerland, for example, Kant definitions is different than in Norway or in Poland. So all these mathematics were actually crucial to describe, to deliver this alignment, and as I said, 10 years just to develop this specific object, and it meant to be released in IFC 4.1, but then, of course, it took more time. That's why we have this in IFC 4.3. What can give us this alignment? So alignment, we can now place objects along alignment. So in infrastructure, if you work in infrastructure, you know that all corridors are based on the alignment, and along alignment, we can place like signals, signs, barriers, or even columns from bridge. So all these objects, all the logic we can now save in IFC, we can attach this to IFC, and we can consume by other applications and reuse this information. So for example, now this information, it's not heavily used, but I see a huge potential in all asset management system where they can consume the data and utilize this information in the facility management stage in the project. Another thing that is very crucial for infrastructure, so buildings or constructions, you can build in the Origo 000, in the coordinated reference system local. But it's not that easy for infrastructure, so you always have to place your project somewhere. So now IFC also supports this approach. So you can attach your project to the specific coordinated reference system, and you have this information in your file, and based on this information, you can also verify it when your file comes into the let's say, software or go outside, and you can verify this information, is it correct or not. So this is just to avoid the mistakes that could happen in infrastructure and are very often if you don't follow the coordinate reference system. So for example, in Norway, there is two different coordinate reference system, NTM and UTM. So NTM is used for design, UTM is used for asset management, but it happens quite often that designers use UTM to design, so they actually have to then transform the whole projects, and it costs much more money than initially. So this is something that it's quite important for infrastructure world, and IFC 4.3 supports that. Geometry representation. What is also very powerful in IFC that they support different definitions of geometry. For those of you working with the software, probably the term called implicit, explicit is familiar, but let me explain you. So explicit, it's the boundary representation, so all points connected together with lines. From this we have faces connected together, we have some meshes or some solids and so on. And implicit, it's the geometry that based on the cross-section, for example, and the line. So we have the whole logic inside, the parameters we have inside. So also the advantage of that kind of geometries is that we save a lot of memory, because if you have to describe the same objects with explicit geometry, with these boundaries, and with the geometry that is based on the logic, it's when you compare the size of the file, of course, this parametric geometry will be much, it will be, not so heavy as the initial one. So we have new definitions. It's called IFC section solid horizontal. It's very important geometry for infrastructure, especially if we think now about IFC as a file that exchange not only the geometries but also logic behind. So imagine the world that you deliver file from Revit and you consume it by Tekla, just IFC file, and you in future you would be you would probably have possibility to change the parameters and send back. So today we just use IFC as a reference. We cannot change the geometry. We use, as I said, only to show the shape or attach our design and refer to another design. So this is the first step to also include the logic inside IFC files. Surveying data, another important aspect of the standard. So we can describe more precisely the data that can be sent to the construction site. And basically, we are talking about the lines, and we talk about string lines. So now is new definitions called annotation, or this is not new, it's known. Annotation, something that doesn't exist, but could be described. And in addition, we have this survey predefined types. So this also help to set up different softwares to be able to consume it and understand it correctly. So this is example how you can send your data to construction site, and based on this, so now it's possible to deliver data, IFC data, to machine guidelines systems or machine control systems, or to stake out based on the alignment on lines. So with this standard, before it was also possible, but not so easy to maybe implement or in the old hardware. But now with this new standard, having this alignment, it's something that everyone look at. So yes, so data IFC from design to construction site, and all these parameters and objects that are there are even more handy to have on the construction site. And at the end, I would like to also tell you about the certification, because one thing is that you export a file, but another thing is that you have to export them correctly. And how we can prove that our data are valid. So Building Smart established the web service called validation, yes, where you can upload your file, and your file will be checked against different rules. And you can see on the left side that some of my files file under some rules, and then if you go deeper, you can also understand what happened to this file. Why also I mention it? Because now certification will be based on this validation service. Before, it was like Revit, Tekla, ArchiCAD, they were certified, but the certification was based on something called MVD, Model View Definition. And you actually had to pay fee to the Building Smart and you got the certification, to be honest. But today, with this solution, it means that, for example, if you are going to use my software, if you are going to export this file and you upload there, and you will get the red mark, it means that my software allows you to make mistake. It means that my software cannot get the certification. So the certification, as you can see on this side, will be based on all these marks. If you have everything green, it means that you can be certified. If you have a red, it means that you cannot. So now certification, it's a completely new approach. It will be for free, but you have to also assure that your data are compliant. And to do that, also, we as a Trimble take also part in the pilot project, where we also decide how it should work. But the thing is, what we are trying to implement, it will be some kind of watermark that you will put to your file, that service will know that this specific file comes from this software, this version, and so on. So we, as a vendors, will also have a feedback on what's happened, why this one doesn't work. And so to prevent that, software also has to be even better in like limitation. That, for example, I'm implementing now IFC in our software, and we don't have limitations. So if you don't know enough the schema, you can do a lot of mistakes. So actually, we as a vendors has to prevent and make these boundaries, these limitations, that you as a user can rely on data and be sure that you don't do any errors. So this is the future. So I hope that more and more softwares will implement this standard. And as I said, I'm an infrastructure engineer. For me, it's a big thing. So I hope that we will see more projects using this standard. Thank you. Any questions? You have some question.
I've played around with the IFC validation service.
Yes.
And I was wondering, because it basically validates certain IFC files. Mm-hmm. So is there like a standard data set of files, of models that should pass through, or how this certification process would use this validation service? Is it then per specific model, or?
So what I can say, so you mean like how the certification process will look like?
Exactly.
So this is like a score map, as you see here. So there is based on some concepts. So IFC has concepts, fundamental concepts that should fulfill. So you as a vendor should rely on these concepts, and these concepts also are part of this MVD, but I don't want to make this too complicated. But at the end, you have your mail from company Arup, so you will provide a file to this service, and you will get the score. And this information with this watermark is attached to your file. So they in Building Smart will know that this file comes from my software, and this score map will show me in which field I'm sucks. So it means that every time you provide an error in Building Smart, they will know, and it also influence our score, and it should be each time. It cannot be like you have 9 passes and 1 mistake, overall is mistake. So you made mistake in this field, so it means that you have to contact Building Smart, and they have to actually update your score map, but you have to also prove it that you change it and you make the difference in the coming version. So it's actually based on the community, because I can also, let's say, I will upload 100 files from my Gmail account, but it doesn't work like that. So it should be like company mail.
Does it have to be integrated in the software so that with each export it automatically gets validated, or?
This is a good question, and we also think about what we should do to be sure that our users provide proper data. What we think at the end, or during the process of export, we will have a validation service that will check before you export. You will get a notification, hey, this class is wrong, or this class has no relation to this object. Please take this. Or we think, okay, if you don't want to correct this, then we actually delete the watermark and just deliver file. If it's correct, then you get this watermark, and then you can test in validation service.
Thank you.
First of all, thank you for your presentation. And I have a question about the future of the exchanging data between different systems in the construction. Because I was working for many years for another sectors, and there are architectural rules saying that data exchange between systems is forbidden to do it by files. It is forbidden totally in banking, telecommunication, but this is not secure. What do you think? How long in our sector we will exchange data through files? If you see the possibility of, do you hear about it? If we start to exchange data, like for example in banking. In banking it was the standard PSD2 because of the new regulation, and now we have a BLIC services and other services, and we're exchanging data in another ways. In our sector still we're exchanging data through file. This is very strange.
Great question. Let me answer your question. And this is not a very complicated answer, because it's all depending on which market we work. So for example, I know that in Poland it will still be an issue to have exchange without the files. So now, even now we deliver, so imagine first step, what we deliver after we finish the first stage of the project, what we deliver. We still deliver drawings and files in addition. We have to actually jump to the stage where we deliver files, and we use these files on construction site. This is the first thing. But on the modern, more mature markets, I'm based in Oslo, Norway. And what we do, we actually, so I don't want to actually talk about the software we have, but this is a good example. So how we interact with the applications, because as I said, IFC is a good exchanging data if you want to reference one design in one software in another software. This is just for a reference. So what we do, for example, we have API connection with different authoring tools, and these softwares stream the data to our platform using this API. So they are not streaming the files, they are streaming the objects, but on the way we have to convert these objects to the objects we have in our platform. And these objects we have based on the IFC library. So you have one big common data environment, which is object-based. So you actually manage the objects, not the files. And ISO 19650 is all about managing files. So, and we are stick to this. We are translating these standards, we are trying to implement this, but we have to understand that actually it's not the modern way of working. So if you imagine if you work on the concurrent engineering project where you design and deliver or design and construct at the same time, there is no time for these processes. So you have to stream your data directly. But still, you need to have some standard to be held to actually to cover some regulations, rules. So I mean, IFC is a good, it's not only file. We shouldn't think about IFC as a file. We should think about IFC as a standard, because this is a big, huge schema describing many things. So in my opinion, we still need the standards. We still need to have some deliverables, that you have to deliver something to the owner, to the public authorities. They have to archive something. But the streaming between stages, so if I am working on design stage and I want to work with someone else, we can stream the data directly without having a files, but as a delivery still you need to have some proof. You have to deliver something that is possible to archive.
Okay, thank you. Let's discuss later during the break. Okay. Thank you.
These new geometry types you've got, they're kind of swept solids, is that right?
Yes, swept solids, advanced swept solids.
And would you also apply a Boolean operation to them as well?
Boolean operation is something else, because it already exists in IFC schema for years.
Yeah.
So this one is a specific, so what is the difference between the geometry I mentioned that is new? That when you have a cross section, so it always pointing to the global Z value, and you can sweep it like this. So if you imagine pipe and the cross section, so pipe can follow your path perpendicular to the alignment. In this case, it's always perpendicular to the global Z direction, like this. So this is the difference.
I guess what I was thinking is, as these new geometry types get introduced into the standard, it sort of implies that you need a more capable modeler behind the scenes for your interpreter, because it's not, if you were just pulling in predetermined faceted data, you know, that's a relatively simple thing, but once you start getting more complex solids and performing implicit operations between, having implicit geometry as a result of the operations between those models, you end up having to have essentially a geometric modeler with some capability to interpret correctly.
And this is a great question, because this specific geometry is not the part of this official ISO certificate MVD. So this is in the schema, but no one has to implement it right now. So this is something what exists, but I saw maybe 1-2 implementations as a proof of concept. So this is there, but not used and utilized. Because I said, still, why we need this geometry if we're only exchanging data as a reference? Why? There is no point to that. Maybe this, I see that, okay, this size decrease, that we don't send so much heavy files. This is the advantage of using that, but what else?
Thanks.
More questions? Thank you.